Good day everyone, my name is Ronan Viterbo from BSMT 129. Today I will discuss the Earth Coordinate System, map projections, and general information on nautical charts. First is the Earth Coordinate System. The Earth in which we live in is roughly spherical in shape. That means it's not actually a perfect sphere. Its true shape is that of an oblate spheroid. For navigational purposes, the Earth is considered a perfect sphere. Our planet, Earth, rotates about a fixed diameter called the Earth axis. The extremities of an Earth's axis are known as the Earth's poles. The Earth poles from which the Earth's rotation would be observed to be anti-clockwise is known as the North Pole. The other pole from which the Earth's rotation would be observed to be clockwise is known as the South Pole. Circles of the Earth. What is a great circle? A great circle is formed by the intersection of a spherical surface with any plane passing through its center. It is the line on the surface of a sphere which divides the spheres into two equal parts. The circle which not pass through the center are called the small circles. What is meridian? A great circle whose plane passes through the north and south poles of the Earth would describe two semi-great circles, which are diametrically opposite to each other. The semi-great circles are called meridians. There are 360 meridians that can be drawn the Earth, which are spaced at 1 degree from each other. And there are 21,600 meridians that be drawn around the Earth, which are 1 minute of arc apart. One particular meridian that passes through the original position of the Royal Observatory at Greenwich, England, is called the Greenwich Meridian or the Prime Meridian. Equator. A great circle whose plane is perpendicular to the plane of all meridians is called the equator. Earlier, it was said that the Earth is spherical in shape, though not a perfect sphere. If it is a sphere, then one half of it is called hemisphere. The equator divides the Earth into two hemispheres. The hemisphere which covers the area of the Earth to the North Pole is called the Northern Hemisphere. The other one that covers the area of the Earth to the South Pole is called the Southern Hemisphere. The parallels of latitude. Define parallel of latitude. Small circle whose planes are parallel to the plane of the equator are called the parallel of the latitude. Sometimes they are also referred to as latitude parallels or simply parallels. There are 90 parallels of latitude that can be drawn from the equator to the North Pole at a distance of 1 degree from each other. Angles on the Earth. What is latitude? The angle that parallel of latitude makes the plane of the equator is called latitude. This angle is measured at the center of the Earth from the plane of the equator to the plane of the parallel of the latitude. Latitude should not be confused with parallel of latitude, as there is a difference between the two. Latitude is an angle while parallel of a latitude is a circle. Latitude is also defined as an arc of a meridian located between the equator and parallel of the latitude. Latitude is the name either north or south. If the latitude of a point on the Earth is 30 degrees, this means that the angle subtended by the parallel of the latitude in which this particular point is located is 30 degrees from the equator. Since the same angle can be described from both sides of the equator, a distinction must be made whether this angle is measured northward or southward from equator. Difference of latitude. The difference of latitude between two places is the arc of a meridian contained between the parallel of a latitude of the two places. It is important to remember the following points in dealing the longitude. The maximum value of a longitude in degrees is 180 degrees. The 180th meridian is diametrically opposite the meridian of Greenwich. The Greenwich meridian and the 180th meridian divides the Earth into two hemispheres, the Earthern Hemisphere and the Western Hemisphere. Longitude is angle, not a circle. The difference of longitude. The difference of longitude between two places is the smaller angle at the pole or the minor of the equator that is contained between the meridian of the two places. These are the rules in finding difference of longitude. Sometimes it is necessary to give name to DLO. In such case, the DLO is named east if the direction of movement is toward the east. It is named west if the direction movement is toward the west. If both longitudes have same name, meaning they are located in the same hemisphere, the DLO is the difference of both longitudes. If they are on opposite side, one east and the other west, the DLO is equal to the sum of their longitude, provided that sum is not greater than 180. In which case, the DLO is equal to 360 minus the sum of the longitudes, and naming it is the contrary name to what is found in usual way. Latitude of arrival. If the latitude of departure is greater than the DLAT, the vessel will remain on the same side of the equator, or its latitude of arrival will have the same name as the latitude from. But if the DLAT is greater, then the vessel will cross the equator and will arrive at a latitude equal to the difference of DLAT and the latitude of departure. The latitude of arrival now assumes the opposite name. Longitude of arrival. When the longitude from and difference of longitude, or DLO, we have same names, longitude from should be added to the difference of longitude. The sum, if not more than 180 degrees, will be the longitude in is of the same name as the longitude from. But if the sum exceeds 180 degrees, subtract it from 360 degrees and the difference is the longitude. And the same name should be contrary to longitude from. When the longitude from and the difference of longitude have unlike names, subtract the lesser from the greater and the remainder is the longitude. It is named the same as the greater. Topic is navigational charts or map projections. What are charts? Charts are representation of portions of the Earth's surface. They are printed specifically for the use of navigator in order that it may present incomprehensible from the trend of the coastline, position of lights, important headlands, rocks, shoals, depth of waters, direction of tidal streams, channels, and all other information essential from the safe navigation of a vessel in navigable waters. What is the difference between a chart and a map? A map is a representation of some parts of the Earth's surface that shows political boundaries, physical features, cities and towns, and other geographical information. A chart is also a representation of a portion of the Earth's surface, but has been especially designed for the use in navigation. A nautical chart is primarily concerned with the navigable waters area. It includes information such as coastline and harbors, channels and obstructions, currents, depths of waters, aids to navigation, and other information that may be useful to the navigator. The aeronautical chart shows elevations, obstructions, prominent landmarks, airports, aids to navigation, and other information that are important to air navigation. Map projection. What is map projection? A chart projection is a mathematically described technique of how to represent the Earth's curved surface on a flat map. The construction of charts represents a problem to chart makers on how to represent a portion of the Earth's surface, which is curved surface, into a plane surface. It is impossible to accomplish this exactly without a certain amount of distortion. To provide practical and sufficiently accurate results, various methods known as projection have been developed. These are the types of charts projection. First is Mercator projection. It's a cylindrical map projection presented by a Flemish geographer and cartographer, Gerardus Mercator, in 1569. It became the standard map projections for navigation because it is unique in representing north as south as down everywhere while preserving local direction and shapes. Advantages of Mercator projection. First is position, distance, and direction can all be easily determined. Second, rhomb lines flat as the straight lines. And the last is meridians flat as a straight lines. And these are the disadvantages of a Mercator projections. First is distortion of true size of surface features increases with distance from the equator. Second is great circles other than meridians or the equator appear as a curved lines. Is genomic projection. A genomic projection, which is commonly referred to as a great circle sailing chart, results when the meridians are parallels of latitude and projected onto a plane surface tangent to the Earth at one point. The genomic projection is made by placing a plane surface tangent to the Earth. Points on the Earth's surface are then projected onto this plane. The point of tangency may be at any location. Distortion is great, but this projection is used in special cases because of its unique advantages. Great circles appears as straight lines, which of course is not so with the other projections. A special case of genomic chart occurs when the geographic pole is selected as the point of tangency. In this case, all meridians will appear as straight lines and the parallels as concentric circles. The result is chart that is used in the polar regions where ordinary Mercator charts cannot be used. The third projection is polyconic projections. Polyconic projections are developed onto a series of cones tangent to the Earth. It is termed of polyconic because it uses separate clones for each parallel of latitude. The vertex of the cone is at the point where a tangent to the Earth at a specified latitude intersects the Earth's axis as extended. The polyconic projections introduce little distortion in shape and relative size are more correctly preserved than in the Mercator projections. The scale is correct along any parallel and along the central meridian of the projections. Parallel of latitude appear as concentric arcs of circles and meridians as curved lines converging toward the pole. This type of projection is not so widely used in marine navigation. Mercator chart. Most of the charts of the world that are displayed in the school's library as well as in public and private office are in the Mercator projections. The Mercator chart fulfills the two main requirements of navigation charts, which are rhomb lines. Lines that cut all the meridians at equal angles should be represented as straight lines so that the courses may be drawn easily. Angles, such as a course angles, should not be distorted. Navigators often use this kind of chart as it's suited to their special requirements because it shows all rhomb lines, including the equator, parallel of latitude and meridians as straight lines. Mercator chart, in spite of its many advantages, has also some defects, some of which are it cannot be used in the polar regions. Every latitude has a different scale of distance. Great circle arcs, except arcs of the equator or meridians, are drawn as curved lines. These are the comparison between the Mercator chart and genomic chart. Chart scale. The scale of a chart is defined as the ratio of a distance unit on the chart to the actual distance on the surface of the Earth. Because it is ratio, it does matter what size unit is or in what system is measured. Example, a scale of 1 ratio to 550,000 means that 1 unit, inch, foot, meter, etc. on the chart represent 50,000 of such unit on the Earth. A chart covering a relatively large area is called a small-scale chart, and chart covering a relative small area is called a large-scale chart. Small-scale chart. Everything appears small, less detail. 1 is to 100,000 means 1 inch on the chart is 100,000 inches of the Earth's surface. Large-scale charts. Everything appears large, more details. 1 is to 1 is to 1,000 means 1 inch of the chart is 1,000 inches on the Earth's surface. Classification of charts. Charts may be classified into groups according to the purpose they serve and according to the specifications of the chart markers. Two major chart manufacturers in the world, the British Admiralty or BA, Charts of Britain, and the Defense of Mapping Agency Hydrographic or Topographic Center or DMA-HTC of the US have classified the charts into the following. First is ocean charts or sailing charts. These charts are small-scale chart. That means a long distance of the Earth's surface is represented by a comparatively short distance on the chart. These charts are used mainly for deep-sea navigation for these reasons. Coastal details such as rocks, shoals that are lining the shores are not depicted. Second is general charts. Are intended for use in coastwise navigation outside of outlying reefs and shoals when the vessel is generally within sight of land or aids to navigation and his course can be directed by piloting. Third is coastal charts. Coastal charts are large-scale charts used when navigating in close proximity to the coast. Many details of the coast is depicted such as nature of the coastline, position and the characteristics of lights, radio telegraph stations, tower and beacons, and other prominent features which are observable from the bridge of the ships and which may aid the navigator. Fourth, plan charts, harbor charts. These are very large-scale charts on which are depicted detailed information of small areas such as harbors, rivers, estuaries, and etc. The last is miscellaneous charts. In this group are included all charts which are not involved in the other three classes. This includes genomic charts for facilitating great circle sailings, variation charts, route charts, weather charts, and etc. Chart scale. The general charts. Small scale charts. 1 is to 1,500,000 minus 1 is to 600,000. Used for voyage planning. Sailing charts. Small scale charts. 1 is to 600,000, smaller, used for open ocean navigation. Coastal charts. Large scale charts. 1 is to 50,000 minus 1 is to 150,000. for approaching bays and harbors and used for coastal navigation, outlying reefs and shoals. Harbor charts, large-scale charts. 1 is to 2,400 minus 1 is to 50,000. Used primarily for inshore navigation and for navigating large inland waterways. The last topic that I will discuss is the general information on navigational charts. The first is title block. Title block, each chart has a title block. This block includes the title on the charts and the statement of the projection used. In the title block, where you can see the crest which is located at the top of the chart title, that will ensure that your chart is an official chart. The main title, which states the specific geographic area of the chart. Nautical scale identification. Natural scale means the relationship between the size of the charts and the Earth, where the scale gives an indication of how detailed the chart is. The depth note is shows which unit of measurement are used to indicate depths on the charts. You may read surroundings in the fathoms and feet or surroundings in meters. Soundings in fathoms and feet indicates that the soundings are in fathoms with subscript in feet. The large number indicates fathoms and the smaller number indicates feet. Soundings in meters indicates that the soundings are in meters and decimeters. You can convert between meters, feet, and fathoms using the depth conversion table provided on the chart below. The depth is indicated on the chart are all based on the chart datum. This could be the mean lower low water or the mean low water or other tidal datum. Lettering styles. The styles of lettering on a chart also provide information. In almost all sources of charts, vertical lettering identifies features that are dry at high water, submerged, and floating hydrographic features, except depths of water, are identified by leaning or slanting letters.